The graphs of polar functions r equals f of theta and r equals g of theta, where f of theta is 4 cos theta and g of theta is negative 4 sine theta, are given in the polar coordinate system for everything in between 0 and 2 pi. Which of the following is a possible polar coordinate for these guys when they're set equal to each other? Well, polar coordinate system, if I were to make the most generic polar coordinate system, it would be a circle very similar to like a unit circle, right? Now let's scooch this over here. Let's get rid of that straight line. If it'll let me, it will. Yippee. Now, the way the polar coordinate system works is you start out at 0. You're given some type of radius, right? So like u would be my radius and u would be my angle, and we would just spin around counterclockwise, right? So, you know, same old things, like your 2 pi and 0, and your pi over 2, and your pi, and your 3 pi over 2. Stuff like that. The graph of 4 cos theta is going to be a circle that lives on the positive x-axis. Cosine is x, so why not be a circle living on the positive x-axis like that? Okay, that is going to be the graph of f of theta. The graph of g of theta is negative 4 sine theta. Regular sine theta lives on the positive y-axis. So negative 4 sine theta is going to live right here. Now, it's probably safe to say that this is going to intersect right here. And it's probably also safe to say that that angle is literally right in between 2 pi and 3 pi over 2. So we could probably safely assume that at the very least, the angle part of this is going to be that halfway point between 3 pi over 2 and 2 pi, which is going to be 7 pi over 4. Now the length, I don't know. What I could do is I could use like midpoint formulas and stuff like that, but I also noticed that the length of it really doesn't matter. And it's at the angle that they really want. And so the answer for this one is going to be D based off of that information right there.